everyone, welcome to my channel Suri Sessions. I've started this channel to help the people out there to learn something new in a way we can use it practically. So that's the theme of my channel, be practical. So the way I want to help you out is the way we learn theoretically and the way we can use that in a practical way. I would like to cover what is SQL, why do we need it, and what are the key concepts within it. So to start with, what is SQL? So maybe many people would have called it as SQL. So what is SQL? So SQL stands for Structured Query Language. So the name itself is very particular. If you see what is structured, so there is a structure within it, and a query, so it can query, and it is a language. So SQL became a standard of ANSI, which is American National Standards Institute, and it is also a standard of ISO standardization. So the SQL is one of the widest and most popular programming languages across the world. So why do we need SQL? We need SQL. What SQL can do? SQL can query against a database. It can talk to the database. It can retrieve the data from the database. It can insert records into the database. It can update, it can delete, or it can do many other things which I want to detail in the coming sessions. So as you all know, like a SQL is a standard, and there are many flavors in the market within the SQL. So as you all know, like there were various versions from the Microsoft. We got Microsoft SQL Server, and we have from IBM, we have various other flavors like DB2 and other tools, and we also got Oracle, and we also got MySQL, and there were so many others in the market. So before we go further, why do we need SQL? As I said, we need SQL. So we need SQL because we want to connect to RDBMS. What is RDBMS? RDBMS stands for Relational Database Management System. So this is the basis for SQL. So as I said, like it can be any flavored. So whatever flavor we are talking about, the SQL always tries to interact with the RDBMS. So before we go further into the class, I would like to confirm one thing. The SQL we follow in this session and the future sessions are ANSI standard, which is widely used in Microsoft SQL Server. So I'll just say SQL from now onwards. So there are slight variations across other flavors like Oracle, MySQL, which we will discuss in the subsequent sessions. So to start with, RDBMS. So what is RDBMS? So RDBMS, the data within it is stored in objects which is called tables. I'm sure you might all familiar with what is tables. Okay, so what is a table? A table is a collection of a data set which is stored in the form of columns and rows. So what is a row and what is a column? Usually a record, we call it as a row, and a column is a vertical entity which contains the information about the record or row. In this case, if you take this example, this is a table where we have 1 and 2 columns, and we have 1, 2, 3 rows. So if you see, each column is providing information about the specifics of the field. Say apple, what is the categorization of apple? It's a fruit. And what is this number 1? It's a quantity. So fruit and quantity are the column values here, and the record or row values here are apple, and the quantity is 1. And similarly, the second record stored in the table as banana and 2. Likewise, orange and 3. Today, we would like to discuss in detail about DDL, DML, DQL, DCL and TCL. So to start with DDL, what is DDL? Data Definition Language. So what it will do? It will help us to define the structure of the database, a table, whereby creating a table or deleting the table or altering the table, etc. So one important thing about DDL is all the transactions, whatever we do, will be auto committed. That means they will save in the database permanently. So what are the various commands we got? We got create, we got drop, alter, and truncate. So we'll go in detail from the practical point of view, but for now I would like to touch upon what are these commands. Create will help us to create a new database or a new table within the database. Drop will help us to delete the structure and record of the table or a database. Alter, what is alter? As the name suggests, it will help us to alter the structure of the database or a table. And truncate will basically help us to delete the data within the table. And moving on to DML, data manipulation language. As the name suggests, we are manipulating the data. So manipulation in the sense we are adding a data, or we are updating the existing data, or we are deleting the data. So likewise, we got three commands. The first one is insert, which can be used to insert the data into the table. Update, which will be used to update the existing records. And delete, again as the name suggests, it will delete the entries from the table. Now the most important thing with regards to the SQL is the DQL, data query language. As it's a structured query language, select has its own importance compared to all other commands. I can say this is the widely used command across SQL. So what is select? Select, as the name suggests, it will help us to select some portion of the data or complete data from the table. So select will be used to select a particular data set from the table. And DCL, as the name suggests, it's a data control language. So basically this will control the data within the database with regards to the access. So the two key commands we use is grant and revoke. Grant will help us to grant access privileges to any user within the database. And revoke, on the other hand, if you want to revoke the existing permissions of any user, you can do that using this command. And now the fifth one is TCL, transaction control language. Transaction control language, we have the three key commands called commit, rollback, and save point. Commit will help us to save all the transactions which have been run so far into the database. Rollback, as the name suggests, in case if you want to undo some transactions or all the transactions you have done so far, you can do that using this command rollback. And save point is kind of a conjunction to the rollback. Say for example, if you don't want to roll back all the transactions we made so far, or you want to roll back to a particular instance or a point of that particular day, you can use that by defining a save point. So on a high level, these are the key commands we use as part of these 5 categories. So now let's go into a practical. Okay, now I have connected to the SQL server. I think I've already discussed in my previous topic about how to connect to the SQL server and how to run the queries. So let's start with DDL first. So as part of DDL, as I said, we have 4 magic commands. The first one is about create. So what create can do, we can create a database and we can create a table. So let's start creating the database using the magic command create, and the syntax will be create, database, and database name. In this case, I would like to give the database name as testdb. So I'll select it, I'll click on execute. You could see the command completed successfully. So let's check whether the database has been created. So as I said yesterday, let's click on refresh and you should be seeing a new database. Yes, here we go. We got a test database. So since we created database, as you can see, there are no associated tables within it. So let's create new tables. So I've again got the queries ready for that. So let's run the query on creating the tables. So the syntax for creation is, again, it's not that difficult. I can explain in the easiest way. the syntax is, so again the important thing is we should connect to the particular database we have created just now. So let's connect to testdb. So now we are in the testdb database, and now let's try to create the new table. Create table, table name, and these are the columns we can add. A customer ID is one column, customer name, address, city, and country. Again, int, varchar are nothing but data types I want to define, and primary key I want to mark customer ID as a primary key, and which is of not null category. So I've inputted all the key details to create the table. So we can use the same syntax to create n number of columns. So let's create the table now. So I'm clicking and I'm running it. Command completed successfully. So let's see if we can see the table created here. Okay, here we go. We got the customer table which is created. As I said yesterday, by default it will be denoted or preceded by a schema called dbo dot before the table name. So as soon as we select it, we can just run it for customers, or we can call it as dbo dot customers. So always the way we connect to the tables are from the db to schema to table. So since we are already in the db, we can directly call the table as long as we are in the same schema. So let's go to the next command. So since we created a table, what are the next command we have? We have a drop command. So as I said, drop will delete the whole table along with the structure. So what that means? So currently we have a table called customers where we have 5 columns with customer ID as a primary key. So let's try to run this command, drop table customers. So ideally it should be dropping the whole table out. So let's check that now. If we refresh it, we could see there are no more tables. So the command has worked. So now since we want to play around with different commands, I will recreate the table again. So let's run this query. So, and the table is back. Okay, so let's go to the next magic command, which is truncate. So what truncate does and what differently it does to drop. So truncate will delete the records within the table, whereby retaining the structure. That means in case if the table has some 100 records, it will delete all those 100 records, but it won't delete the table altogether. The table will remain intact. So the structure will be retained so that we can add new data into the table at future point. So let's run this query. Command completed successfully. And if you see that the table is still intact, it's only the data within the table is deleted. So now the other important command is alter. Alter will help us to do altering the table. So we can add or we can drop content from the table with regards to the structure. The first command we can use is alter table, table name. We can add column and the data type. So in this case, since we already had a table called customer, so let's run a command where we are altering the table customers. We are adding a new column called test, which is of integer. So let's run this. Command completed successfully. So let's refresh it. So we should be seeing the new column test. Here we go. We got the test, which is of type integer and can be nullable since we have not defined as null, not null. So let's play around with the drop command now. So similar to adding, we have to click on alter table customers and drop column test. So let's drop the column which we created just now. So let's refresh it. Ideally it should not present anymore. Here we go. It's all been deleted or dropped from the table. So that's all about DDL. So let's go to the next categories. So again, I have created the queries for that. So let's go through them one by one. So the first one is DQL. So I want to first touch upon DQL because this is the key command which we are going to use, which will help us to define our DML and DCL or TCL commands. So as I said, it's only a single command, which is a very powerful one, which we are going to do on day-to-day basis. So let's do the select command. So the syntax for that is, we have to enter select and we have to mention number of columns, or if you want to get all the data from the table, you can denote as star. Star refers to complete data set. So select star from table name. In this case, the table is customers. So what will happen when I run this? Any guesses? It should not throw up any data, as we have created the table, but we never added any data into it. So it's asking me to connect. Yes, I will. So you can see here, the table contains no data, but the structure is still there, as we have created the table very recently. So now, so the DQL point of view, it's only one command which can help us to read partial or a complete data set from the table. So let's play around with the next category, which is DML, data manipulation language. So the first command here is insert. So I want to insert particular amount of data within the table. So what's the syntax? The syntax is insert into table name, and we have to mention column names as well, column 1, column 2, column 3, and values. What are the values for each column? So it's pretty straightforward. So for the customer table, I would like to insert values. So one important thing I would like to tell you here is, the parenthesis which contains the column names is optional. It's up to you. If you think you won't remember the column names, you can write them straight away here, or if not, if you are confident enough, you know the column names, then try to put the values in the same order. So we need to make sure whatever data here, it's all one-to-one mapped. So 1 refers to column 1, 2 refers to column 2, likewise column 5. So the first command I'm running here is, as per the syntax, I'm inserting data into customers with the values of 1, test 1, so and so. So what will happen when I run this? It says one row affected. That means something has been changed within the table. So how to see whether it has been added or not? So let's use our popular magic command, select. Select star from customers. So let's run this. So ideally we should be seeing the one row. Yes, we can. So we can see the data has been added. Say you might be thinking, it's a tedious task, we can't add one row every time. Why can't we add multiple rows in single go? Yes, we can do. So in order to do that, we have an option within the insert command where we can add n number of rows by separating a comma. So you can see a same syntax, insert into table name with the values. This is the first row. So second row, likewise you can add number of rows. But for now I'm adding 2 rows. So let's run this command. 2 rows affected. So any guesses how many rows will be available now in the customer table? It should be 3, because we already added 1 previously. Now we added 2 more. So let's try that. Yes, we can see that 1, 2 and 3. We can slowly see the data is shaping up within the table. So let's go on with the next command. Okay, update. What is update? Say for example, we have added 3 records and you might be thinking, oh no, something wrong with one of the record. What should I do? So we have an option. We can update particular table for number of records or for all records. So how can we do that? With the update command, the update syntax is, we'll do update table name, set is the keyword, and we have to mention column name and the values we are going to add. And where condition is optional, but it's very important. If we don't define the where condition, it's gonna update all the rows. So let's try with one simple update. So I'm updating customer table. I'm setting customer name as testing2 for the customer ID equal to 2. That means this particular record, I want to replace test2 with testing2. So what will happen now? If I run this, I could see one row affected. So let's see what has happened to the record 2. So again, I'm gonna use the magic select command and I'm going to check whether it's been populated. Yes, we can see now the customer name is now set to testing2. So the update statement worked. So likewise, say for example, if you have not given any where clause and if you have ran this, what will happen? It will end up updating all the rows within the table. So if you run this, you can see customer name has been reset to testing2. So it's a bit of mayhem. So please make sure you always use the where clause, otherwise it's gonna screw up your data. So I'm going to change this back now. So I'm going to run the first one as test1 and second one as test2. Likewise, the third record as test3. So now if we see the select statement, we could see it's reverted back to the normal. Okay, the last command within DML is delete. What is delete? Delete command, as the name suggests, it will delete data from the table. Similar to update, we have a where condition here, which is very key. Otherwise, it's gonna delete everything from the table. So the simple, say for example, if I just run this query, it's gonna delete all the data from the table. I don't want that to happen. So I'm going to add a where clause over here. So where I just want to delete the last record. See, as soon as we are trying to enter the column name, it's popping up with the column values. So I'm going to delete the last record, which is of customer ID 3. When I run this command, you can see one row affected. So let's see using select query whether the data has been deleted. Yes, we can see the number 3 has been deleted. So that's the importance about delete command. So let's move on to the next set of categories, which are very key one, although not very important with regards to the data, but very important from the process point of view. So the DCL, as I said, we have two particular commands, grant and revoke. Grant, what grant does is grant will grant some privileges on particular object to a particular user. The syntax is grant, and you can select any of the privilege. Say for example, if you want to grant select, or if you want to grant everything, select, insert, update, delete, which is all DML and DQL commands. So if you want to grant all on, I think I need to select the database here. So grant all on customers to test. I don't have any role defined, but this is the syntax. If you want, you can play around, you can run this, but it will throw, there is no user tests. But if you want to add to any existing user, you can do this command. So likewise, if you want to revoke particular privileges from the user, you can do on the same way. You can use revoke all on customers from test. So this command will revoke all the access privileges from the customer table. So likewise, we have the final category called TCL, transaction control language. So TCL, the first command we got is commit. What is commit? We are committing it. That means we are saving the changes. So that means it will save the changes. How do we do that? So I will show up a sample query. So again, as I already stressed upon, all the DDL commands will be auto committed. You don't need to press commit. But if you want to do a manipulation, you can always play around. So before we play around with examples, let's cover the rollback. Rollback, what does rollback do? It's a other way to the commit. It will roll back the changes we made. So let's try to play around on save point. What is save point? As I explained, save point will try to create a particular save points within the transaction so that we can have a facility to roll back those group of transactions. Rather than rolling back everything, we can roll back up to that particular point. So let's move on and try to play around these three commands. So the first one, so before we go, let's see what data we got from the customer table. So let's run our magic command. We could see there is no data. Interesting. Okay, I think I did the truncate on the other day. So let's try to insert it using our insert command. Two rows impacted. So let's try to see what's the data we got. Yes, we got 2 rows. So now before we act on any of these 3 TCL commands, we have to follow a syntax called begin transaction. So the begin transaction will do, it will begin the transaction and we can play around different manipulations within the transactions and we can decide upon whether to commit, rollback or save point. So let's start with commit. So the syntax is begin transaction. So what I'm doing here, I'm trying to insert some more data into the customer table with our insert statement. So again here I'm adding test 3. So I think I'll probably make it as first one because I have not added the first one. So I'm inserting one row into the customer table and I'm committing as well. So let's run this. That means whatever I have added, it will be committed now. So let's check whether we can see the 3 records now. Yes, we can see. So now as we have committed, let's play around on the rollback. Say for example, we are adding one new record within the customer table, but this time instead of committing it, we are rolling back. That means, oh no, I made a mistake. I don't want to have this record anymore. Let's roll back to the previous commit point. So if I run this query, you could see one row affected, but we also ran the rollback statement. That means this record will no longer present as we have rolled back to the commit, which is at the start. So now let's check what's the data within the table. So you could still see 3 rows. We have not added 5 anymore. So now let's play around on save point. So now instead of rolling back, I'm actually saving this particular transaction to a save point, save P1. So let's run this command. When you run this, you could see one row affected. So let's see what is the data set within the customer table. So you can now see there is a new record with customer ID 5 created successfully. Now what I'm going to do is I'm going to add another record into the table and I'm going to rolling it back to a save point and see what happens. It's quite interesting when we play around with this. So let's start with this. So we are going to add new value called value 6 and I'm going to run this query first. So this will actually insert one record and I'm also, okay, one important thing, when we are selecting multiple lines, SQL is gonna execute all the lines one by one and it's gonna display the output of it. So in this case, you could see you have inserted successfully. You can see that in the message, one row affected, which is for the insert, and 5 rows affected, which is for the select. So let's go to the results. You could see that number 6 has been created. So since we have not rolled back so far, we have data of 5 rows within that customer table. Now I have thought, oh no, I have actually added a row with customer ID 6, which I no longer needed. At the same time, I don't want to roll back to the previous commit point. So what I want is I want to retain customer ID equal to 5 but not 6. So then what I can do, since I've already had a save point P1 saved, I'm going to rolling back to that particular save point. Let's run this. Command completed successfully. Now let's check the data within the table. So what our anticipation is, customer ID 6 should be no longer present and customer ID 5 should still be there. Yes, that's the case. So we can still play around with commit, rollback and save point. Likewise, depends on the situation and the usage, you can play around these three commands. But whenever you do DML commands, make sure you commit it. Otherwise, you might lose the data if you roll back, or if anyone working on the same database is rolling back accidentally. Today, we would like to discuss the key differences between three important commands: drop, truncate and delete in the SQL language. It always runs up in the programmer minds, what are the key differences between these three commands? How can I differentiate them? And most importantly, it's a key interview question as well. If you are going for any interview related to the SQL, this is one of the key questions the interviewer wants to assess it. So this will give us a clarity on the SQL concepts. So before we go further, I would like to touch base the key difference between these three. As we have already studied in the previous session, the drop and truncate commands are actually DDL commands, which are part of data definition language. So by default, they will auto commit all the transactions. And whereas delete is from DML category, which is data manipulation language, which requires commit to commit the changes. So let's play around with our existing tables and see. I'm going to explain the key differences between these three. So let's start with drop. The drop, what it does? The drop will actually delete the whole table along with the structure. What does it mean? That means you can see under customer table we currently have 3 records. So I have run this query, select start from customers. You could see 3 records here. So what drop does is it's gonna delete all 3 rows here, and it will also delete the whole table. That means you can no longer see this table listed out under the tables. So let's do that and see what will happen. So command completed successfully. So let's refresh it, and you can see the table is no longer present. So this is the quickest way to get rid of any table by using the drop command. Now let's do the truncate. So since we don't have the table again, so let's create the table. So to create the table, we should again use the create command, which we have learned previously. So let's create the table. So I'm creating it. The table is created. I'm also adding 3 records into it, similar to the initial state. So let's run this query and see if we can see the 3 records. Yes, we can see. So let's move on. So let's try playing on the truncate. The truncate, as we discussed, it will delete the records within the table, but it will retain the structure. That means we will only drop the records but not the table. So let's run this. So we are expecting the data will be deleted but not the table. So let's run this. Command is completed successfully. So let's check the table is present. Yes, it is present, and it has all the columns, I suppose. Yes. So now let's try fetching the data from the table. So here we go. You can see there are no records present in it. Since we have truncated it, it has deleted all the records. So now let's go back and see what is the difference between truncate and delete. So before I do that, let's try to add the data again. So now we can see customer table holding 3 rows again. So now let's delete it. So what will happen? So again, as I said, delete can be used to delete all the data or a subset of data. If we use where clause, we can delete the particular record. But in this case, on a high level, I want to delete the whole data and see what happens. So this behaves almost similar to truncate. So if I run this command, it has deleted all the 3 rows and it has retained the structure of the table. If you select this, you could see select star from customers actually yielded no records. Then you might be wondering, then what's the difference between truncate and delete? So the truncate, the basic difference between these two is truncate will actually truncate the table in one go. That means it will delete the whole data set in one go. Whereas delete will actually delete a data one by one. So that means it can be delete everything in one go, or it can be used to delete subset of rows. Whereas in truncate, you can't do that. Either you delete everything or you can't use the command. So there is no where clause within it. And also, as I said, drop and truncate are DDL commands, so you can't roll back. So whatever records or table you have dropped, you can't go back to the previous state, you can't roll back anymore. Whereas in delete, you can always roll back and you can ensure the data within the table is back to the usual state. So these are the key differences between drop, truncate and delete. Today, let's discuss about one of the most important topic within SQL, which is joins. I'm sure you might have heard about this joins and the types of joins. So let's cover them on a high level. What is join and what are the various types of joins and how we are going to do that in a practical way. So to start with, we got predominantly 4 types of join: inner join, left join, right join and full outer join. So what are the differences? So let's go for inner join first. As the name suggests, inner join will only extract the information which is present in both the tables. If you see here, we got a table A, we got a table B, and the highlighted area is an intersection of both table A and table B. So if you see here, we are going to extract only the matching information which is present in both table A and table B. Now coming to the left join, as the name replicates, it's basically the priority is on the left hand side. So we are going to capture everything from the table A plus the matching records between table A and table B. So you can see the highlighted area here. We are highlighting all of table A plus the common area between table A and table B. So likewise, right join is the other way. We are going to prioritize on the right side of the table. So here we are going to extract everything from the table B plus the matching records between table A and table B. And now the last one is full outer join. As the name suggests, it's pretty much everything. We are going to extract data from table A and data from table B plus any matching records from either side. So predominantly these are the 4 important types of joins. So since we got some synopsis about it, so let's go into the practical way and learn based on the tables. So let's start applying our principles on the joins in a practical way. So to help us understanding better, I've created some tables. I've also inserted data into it, and then I'll detail about each join. So if you want to view the data quickly, we can see like what's in customers table. You could see there were 3 records with customer ID 1, 2 and 3. And similarly in the sales table, we could see there are like 60 records with sales ID, customer ID, product name and quantity. So now what situations will arise in real time where you need to apply joins? Say based on these 2 tables data, imagine your business user has come up and say, okay, can you tell me how many products the customer 1 has placed so far? So if he is going to ask that information, it's basically we need to categorize that into database level. You could easily sense it. Oh, we need customers data and we need sales data. So we are going to get it together. So that's where you will apply the principle of join. So in this case, let's start with an example of inner join. As we already learned, inner join basically extracts the common data between both the tables. So in this case, I would like to see what sales has been achieved from each customer point of view. So to come to the syntax, I will help you on the quickest way. So what we can do is, like, by default, we will have a select command. So to start with, just select all the columns, and from, so here we are going to input the table names. So you could see the first table we want is customers, and we want sales. So the syntax for joins is, we need to select whatever columns we need from below tables. So the way we join is, we'll put the table 1 and then we are going to join the command. So in this case, I wanted to use inner join. Inner join sales. On what basis we are joining? That's important. So here we need to use the command on. Say I am renaming customers as C and I'm putting another alias for sales as S. So this is the easiest way, otherwise you are going to write customers dot column name. So instead I'm using that aliases. So now I'm going to do C dot. You could see what is the primary key and foreign key between these two tables. You can see the customer ID is present in customers table and also it's present in sales table. So here customer ID is a primary key in the customer table, whereas it is a foreign key in the sales table. So let's use that join as a join condition. So here I am going to write customers inner join sales on C dot customer ID equals to S dot customer ID. So now we have joined. So if you run this straight away, it will extract everything from both the tables. So but again, like, let's filter this out with good amount of information. So all I want is, like, from customer point of view, I just want, like, what is the customer name and from what country the orders have been placed and what type of product the customer has ordered and the quantity. So if I want to get this information, if I run this query, we can easily get, oh, we got, like, customer 1 has placed 3 orders, whereas customer 2 placed 2 orders of these quantities. So we can also use order by for better viewing. So we'll just order by based on customer name. If you run that, by default it's in ascending order. You could see customer 1 we got 3 orders and customer 2 we got 2 orders. So this is good. So in this way we got information for the products which have been assigned to each customer. But there is one important thing we are missing here. You could see in customer table we got 3 customers, whereas in this join query we are only seeing the information of 2 customers. Why? That's because the customer 3 might not have placed any orders, but when you are submitting a report to your business users, you are going to show that somewhere. How do you do that? So that's where you would need left join. So the same statement with the same syntax, if you copy paste, and instead of using inner join, you can simply use left join. And what it does is very interesting. If you select this, you could see customer 3 of country UK, there are no products associated in the sales table. So in this way, we can show up in the reporting that, okay, customer 1 has placed 3 orders, customer 2 has placed 2 orders, whereas customer 3 have not placed any order. So that's good. This is giving a complete information between customers and the sales. So likewise, you would use left join when you want to fetch the details, everything on the left hand side and the matching records on the right hand side. So now let's go the other way, right join. Why do we need right join? Again, a similar principle. You could see here we have listed 1, 2, 3, 4, 5 products. In the sales, you could see there are 6 products. So we are missing some products here. Say for example, if the business wants to know what product has not been sold yet. So to know that, we use the same syntax and the command. So instead of left join, we'll just do right join. So keep in mind here our priority is on the sales end. So that is the reason we are using right join. So if you execute this command, you could see the product webcam was not sold to any customer since the customer name is blank or null. So I think probably the order by I'll do product name, so it will give us better viewing. So let's do this. If you run this command, yes, you could see the 5 products has been bought by few customers, whereas the webcam was not sold at all. So this is giving a right picture, and business can make effective decision on improving the marketing for that product. So it all helps in the end. So full outer join. Say for example, the business just want to know how many customers have placed orders and what products have been sold so far. Can you give all that information? So in this case, you could simply do a full outer join, which will give us literally everything between both the tables. So let's do full outer join. So you could see here, okay, order by I'll probably do customer name and product name. So that will give us better viewing. Yes, you could see a customer name webcam was not ordered by any customer, whereas the other products have been sold to customer 1 and customer 2, whereas customer 3 has not bought anything. So this is giving a complete picture and a relationship between both the tables. So in a nutshell, like, we can use different commands to cater information at various level. Depending on the requirement, you need to decide what join we need to apply. So now we have seen for 2 tables, what if the information is present in more than 2 tables? So in that case, I'm going to give you another example. So I've created another table called products. If you see the products, the product table is giving an information about what is product ID, what is sales ID, what is product name, and what is the currency, and how much is the price. So here you could see, by seeing this, you can sense one thing. Okay, let me run these 3 commands together. So you could see in the product table we got product ID and we got sales ID, and the sales ID is a foreign key in product table and it is a primary key in sales table. And similarly we got customer ID, which is a customer primary key for the customers table and a foreign key for the sales table. So now you might have got the logic behind it. So all we need to do is like add one more join to our master join. Say in the same query, I can do write another inner join for products. One second. Yeah, I'll call it as P on P dot, you know, the join condition, which is sales ID. So the sales ID is not present in customer, but it's only present in sales, S dot sales ID. So you could easily see customers joined to sales and sales joined to products. That means all 3 tables have joined. So you could see there is a warning sign here, ambiguous column name, product name. This is because the product name exists in 2 tables, sales table as well as product table. So SQL is asking us from which table we need to pick the records. So here you could say, since we are mostly interested in the sales, I'll pick the product name from sales. So now we got the product. So now I want to add another column called price. Since we got a join condition on product table, I would like to see what's the price of each product. So when you run this query, you could see a customer of a country of whatever products he have been purchased and the number of quantities and the overall price. So likewise, this is giving a complete picture. So based on this requirement, we can see what data is being processed across each table. Say the same query, if I do the full outer join, you could get the complete information about what customers have placed order, what products have not been sold, and what is the price for them. So let me do join, full outer join. See, when you run this query, you could get literally everything. You could see only customer 1 and customer 2 have got matching products and they bought these many quantities of this much price, and customer 3 have not bought any product, and webcam as a product was not sold to any customer, and similarly the price for 30 was bought by some customer who is not exist in the customer table. So likewise, based on the situation, we should use the respective join, but always remember the syntax where we need to put the table name followed by the join type followed by the join condition by using the keyword on, and you need to define the relationship between the primary and foreign key. Today let's discuss about another important topic with regards to the group by, aggregate functions, having, and order by queries. So before we go into the practical way, let's first discuss about these concepts in detail, and then we can play around with the practical examples and see how we can actually filter the data using these functions and the commands. So I think to start with, let's first discuss about the aggregate functions. What are aggregate functions? As the name suggests, aggregate functions help us to aggregate the data from the available data set. Say for example, if you want to sort, or if you want to count, or if you want to do play around with the data, if you want to see what is the maximum earnings, what is the minimum earnings, and how many employees you got. So likewise, there are so many real-time scenarios where you need to see the aggregation of the data. So in the SQL, we got these 5 important aggregation functions which can be used along with the select statement if you want to aggregate the whole data. So coming to the first one, min function, as the name suggests, it returns the smallest value of the column. So as soon as you input the column name between the parentheses, it will dictate what is the smallest value available within the SQL table. And on the other hand, max will return the largest value of the column. So it will again go into the table and check what are the values the column is holding, and then it will pick up the largest value of it. And count, as the name suggests, it will count the number of rows matching to that criteria. Say for example, if you input count of particular column name, it will count how many records it's holding within the table. Sum, as the name suggests, sum will return the sum of the column. So as soon as you put sum of particular column, it will sum up all the values it's holding within the table. Whereas average, which returns the average of the column. I hope you all know what is average. So it's basically on an average based on the number of records, it will divide by that particular number. Say for example, if we have 1 and 2 records, it will basically do 1 plus 2 divided by total number of records, which is 2. So that's the value it's going to throw up. So likewise, we have these particular 5 functions which we can play around in the SQL. So before we go into the practical examples, so let's talk about another important topic within SQL database, which is group by. What is group by? Group by, which actually groups the data sets from more than one table. You might be thinking, oh, we already have a join command where we can actually group the data. Yes, you can use join command to join the tables, but in order to group the data sets from that particular tables, you should use group by. And the important thing about group by is it can be used with the aggregation. So that means you can play around the select statement using the group by as well as aggregate functions. So this is most powerful command which will be very helpful when you go in the real time if you want to group particular data along with the aggregate functions. This is your best spot. And having, what is having? Having is kind of a substitute for the where clause. As you know, the where clause will actually put up a condition when you do the select statement, but the where clause will work only for the non-aggregated functions. What if the select statement already holding some aggregate functions, and if you want to use group by along with where clause, it won't work. You should be using having clause, which will help us to define the particular condition to filter the data. And another important command is order by. What is order by? Order by sorts the data, basically the output data, whatever we retrieve using the select statement, it will sort the data in ascending or descending order. By default, if you don't mention anything, it will sort the data in ascending order, which is from smallest to largest or A to Z, whereas descending is the other way, largest to smallest or character Z to character A. So lie around in practical examples. Let's start with the aggregation functions. So to start with, I think as we discussed, I've prepared some queries to play around with the 5 aggregation functions. So before that, let's see what data we hold in the product table. So the product table is holding 10 records with the list of sales ID, product name, currency, and price. So let's start using the aggregated functions. The first one I want to see, since we have a price as the key numeric column, I wanted to play around with that. So I'm going to write first statement as select main of column name. In this case, I want to see the price. What is the minimum price for this table? So when you run this command, it's going to show up the minimum price. You could see from the data 5 is the minimum value. So let's see what will turn up here. So you could see 5 as the output. So you could see it's saying no column no, because we have not defined any alias. You can even call this as like minimum price. So that will give us a column name as minimum price, which is of 5. So likewise, what is the maximum price? So it's again going to the table, which is 1000. If you go to the table, you could see 1000 is the maximum price, even though it holds for a couple of records, but still that's a unique value we got. So now average, as I said, average will actually sum up all the records and it divide by the number of records. So let's go with the average function. In this case, it's going to sum up everything and it divides by number 10. So let's see what's the average price. So this is it. This is the average price we got. And now I want to see what's the sum of the price. So it's basically the total value of the prices. So let's see, it is 3135. So you could see 3135 is the sum and average is 313.5, which is basically 3135 by 10. So now count of product name. So why I want a count? So why in this case I have only put product name, not price. You can even put price, but why I put product name was, since count will actually provide the count, you can use any column from this record except the sales ID, because ideally you should always use the unique column. So in this case, instead of product name, I think product name is also not unique. I'll probably use product ID because that's unique for that table. So when you use this, it will give us 10, which is correct because we got 10 records. What if I use product name? Any guesses? Since we have in total we got only 7 products, but we got a repetition of 3 products which was assigned to particular sales ID. So when you do that, it will only give you 10. Why? Why it's not giving 7? Because it's not unique. So why we got 10? Ideally we shouldn't be getting 10. We should only get 7 products we got. But SQL cannot define whether it's a unique column or it's containing any duplicate records. So to avoid that, we have a command within SQL. If you put distinct in front of the column name, now see what happens. It will only count the distinct values of the product name, which is of 7. But if you use this distinct for the product IDs, the count will still be 10. You know why? Because product ID is a primary key which is always unique. So to be on safer side, even if you forget distinct, I would suggest you use the primary key always. That will give you the actual count of the records. But there is another option you can do. You can simply say count star. What will happen? It will just count everything which is of 10 records. So you can do count star, or you can define a column name. So likewise, these are the practical examples for the aggregation. So now let's go further ahead with the group by, having, and order. So in order to group by, having, and order by, so I've created a syntax which we need to follow for all the queries. The syntax is, you should first put up a select keyword, and you should define what column names you would like to fetch, and whether you would like to use any aggregation within it, from what table you want to retrieve the records. Then you need to define the group by, on what column names you are actually grouping the data, and then having, if you want to use any condition while grouping the data, you can use having, and then order by. As I said, by default order by will always do the ascending. In case if you want to do descending, then you can put DESC, which denotes descending. So this is the syntax if you want to use group by, having, and order by in one single query. So now, since we got data and since we got basic understanding, let's play around with some examples. So let's go to the customers table. If you see the customers table, you have 3 records in the customer. So now if you do, say for example, I would like to see for each country how many customers we hold. So when I do this, so you could see here every customer as a unique country. So ideally when I do this command, it's going to give me a country name and the number of customers within the country from customers table, group by customer name. I think it should be country, since we want the grouping on the countries. So when I run this command, what will happen? It will give you 1 1 1, because we have only one customer per each country. What if I want to say, for example, I'll insert one more record into customer, so whereas I'll call it as number 4 and name is customer 4 and address can be anything. I'll just put Forter Street, and country I'm going to put London, sorry, city London, and country UK. So now I have added one more record, one row affected. So let's search now. Now we got 4 records. So if I run this query again, what will happen? Now you will see the difference. You could see country UK, you could see 2 records now. So the group by command is helping out to see the data grouping based on particular column name. In this case, country. So now let's go further and use some other aggregation functions along with the joins. Since we already played around with the joins, what I'm doing in this command is I'm joining customer table with sales table and product table based on the primary and foreign key. And what I want to know is, like, I want to see for each customer how much money they have spent as part of the sales. So to achieve that, I'll put up the command select customer name, comma, aggregation. Here I've used sum of price and I'm aliasing it as price. Now group by customer name, order by is also customer name. So let's run this query. When you run this query, you could see customer 1 spent 2505, customer 2 3, and customer 4 530. Why there is no customer 3? Since we don't have equivalent records within sales and product table when you do the join. So if you want to see why it is missing, you can always use left join, then you will know what happens. You could see customer 3 is null because customer 3 haven't spent any money, he haven't made any sales. So let's go back to inner join. So now this has given us a grouping of the customer names followed by the price they have spent. So this is one way we got it. Now let's go one more step and let's do, what if I just want to see how many customers have actually spent more than 100 US dollars. So in order to do that, we have a having clause which we discussed. Having, so what I want to define here is, I want the sum of price should be at least 100. So what I do, I'll put sum of price greater than 100. Now what will happen? Ideally we shouldn't be seeing customer 2. Yes, here it is. Now you could only see customer 1 and customer 4 because customer 2 has spent less than 100. In this case it is 30 US dollars. So using these commands you can aggregate, you can filter the data, and you can order the data. Since I ordered by customer name without any details, it's going in an ascending order. If you want descending, you just put DESC command, then you should see the descending order, cust 4 and cust 1. So in a nutshell, this is how we use group by, having, order by in conjunction with joins, in conjunction with aggregation. So this query is very powerful. You could see we are doing aggregation, group by, having, order by, joins. So in real time you should come across in such situations where you have to use all these 5 scenarios. So keep in mind, based on the situation, you can use the respective aggregation and respective grouping and respective filtering. Today let's discuss about another important topic in the SQL, which is wildcards. So let's discuss what is wildcards, why do we need this, and what is the importance of wildcards when doing the select statements, and what are the operators or commands we use where we can use these wildcards. So to start with, to give a glimpse about wildcards, what is wildcard? Wildcards are used in the select statements. So whenever we do select star from the table name, there are some situations where we need to use some wildcards to simplify your search. So you use it along with the select statements, and you will use it as a substitute. The substitute in the sense, say for example, you want to search for the particular character, but you don't know the complete character. You might remember, okay, it starts with something or it ends with something. So in those scenarios, you could use wildcards. And similarly, yes, if you want to find more than one character or for one character, so it can be for a character or multiple characters. And most importantly, wildcards are used with like command in conjunction with where clause. So as we already discussed about select statements, which includes where clause, so we are going to club around where clause with the like command, where we use all these wildcards. So as I said, like, we are going to predominantly use the like command to play around with these wildcards. So in a nutshell, we got, these are the wildcards listed over here. So there are 5 essential wildcard characters we are going to use in the SQL queries. The first one is %. Percentage basically denotes the character's position, whether the percentage it's starting with that character or ending with that character or including that character at any position. It denotes about percentage. I've given some examples where we detail separately about %. And the second thing is underscore. So underscore wildcard character will be used as a substitute for one character. Say for example, you know, Suri, if you don't want to put S at the start, instead you can put underscore and URI. You can use like that. So this wildcard is used for that. And square brackets. Square brackets, we use it if you want to use it to find some list of characters within the search criteria. And the next one, a caret or an exponent. So here, this is the opposite to square brackets, where here we don't want to find for that particular set of characters but everything else. And hyphen, this is basically denotes the range. Say if you want to find some particular range like A to Z or 1 to 10, you can use this particular wildcard. So let's talk about some examples. So I have listed out few examples which covers on percent, as this is the most widely used wildcard. So as I said, percent denotes the character's position. So you, depending on the character and depending on the usage of the percentage, the search criteria differs. If you start with the first one, say for example, if you use a select statement where say like the column like T%, that means here if you see the character starts with T and percent means it can be anything after T. So if you want to search in those scenarios, you will put T%. The other around, if you want to search the last character, you can just put where column name like %T, which will denote all the values ending with T. And similarly, if you know the characters which can exist across anywhere, like in the middle or between start and end, maybe third position or fifth position, if you want to play around in that way, you can use percent set of characters and percent. And similarly, if you combine first one and second one, if you want to search for a string which starts with particular character and ends with particular character, you can use this T%T. So all these four set of examples were related to value test. You can see it's starting with T, it's ending with T, it contains characters or letters E, S, and it's again starting with T and ending with T. So you can play around these kind of examples depending on the usage. And say for example, if you want to conjunct few wildcards, here is one example. Say for the test, you just wanted to say, oh, I want to start with character T and second character can be anything, but the third character should be S and fourth character can be anything. So basically this denotes it's something is there at the end and you're starting with T, E, S. So instead of E, we just put T_S%. That means any set of string which starts with T, whatever second character S, it will list out that particular set of string as an output. So I hope you got a glimpse of what is wildcard, what is like command, and what are the various wildcard characters we can use. So let's start playing around in real time. So let's go into the SQL server and let's use these examples. Okay, here we go. So to start playing around the wildcard, so let's see what we got in this particular table, customers, which we created earlier. So you could see customer table as 5 records with the columns customer ID, customer name, address, city, and country. So let's start using some wildcard search criteria and then we'll try to retrieve the records accordingly. As I said, if you want to use wildcards, the default syntax is select star from table name. You must use where clause and whatever column name you would like to use. And most importantly, the like operator should exist. So without like operator, you can't search for the wildcards. So keep in mind, it's very essential that we follow this syntax. Select command including where and like operator. So let's start with the first one. So you know what is the data under customer table. You could see we got 5 records in customers. So let's search the customer table where I want to view the records where customer name starting with C. So as you can see, we have 4 records. So let's see what will be the output. So I'm going to execute this and you could see, yes, we got 4 records because it contains C as the starting letter. So now let's do the other way. What, as an address, if I want to find any record with T as the last character in the address. So let's search it and see what we will get. See, you could see all these 4 records were having T in the last position. So you could see 1 test rate, 2 test rate, likewise. So similarly, now I want to play around the other behavior which we discussed earlier. I want to define what will be the starting character and what will be the ending character. Now I want to view the records. So in this case, I want to view customer tables where city like starting with L, ending with N. So let's see what will happen. So here we go. You could see 2 records populated where city is London, which starts with L and ends with N. So now we have used various combinations. So what if I know only partial characters and if I want to find anything which contains those particular set of characters? So if you search this, where I am searching for customers table where address contains characters test. So you could see again 4 rows because it contains test in the address column. So likewise, we can play around with the %. So let's go around with other wildcard commands. So I've again created some examples for our quick reference. So here, so underscore, as I said, underscore, we will use it to mimic one of the characters. So in this case, if I search this, we are asking SQL, okay, come on, can you retrieve some records from the customers table where city is like something at the start and it contains the letter ARIS. So when you search it, SQL will search in the table and it found out one record with city as Paris. You could see we have substituted T with underscore. So this is a very important command. And similarly, let's play around on the square brackets. Say in this case, I don't want to say one record. I could say, okay, set of characters, if it contains, it starts with that particular letter, can you define me? Can you show me the output? So if you search this, you could see, yes, it has listed out 2 records where city is London because it contains the set of characters LON at the starting position. So likewise, if you want to go, okay, now I want to see, I don't want any cities which starts with letters LON. So if you want to do that, as I said, you should use the caret or exponent symbol. So let's search this. So you could see here, we are getting all other rows where city is not London. So likewise, say if you want to merge this, okay, now what I want is, I want to search a city which has P in starting position and it has got some set of range of characters after P and then it has got R. So we want something like P with set of characters and R in third position and anything else after that. So when you do that, this is very interesting. You could see 2 records which are displayed. That's purely because if you see, the city contains P in starting position and R as a third character. Since we have defined the range A to E, that means anything between A and E, that is A, B, C, D and E, it's going to display. So that is the reason we got Paris as one record and PER, pair as other record. So likewise, we can use and we can combine, merge these wildcard characters. So similarly, I have written another example where I want to view the numeric range. So in this case, I wanted to see, okay, from the customers table, I want to fetch records where customer name like cust, C-U-S-T, with any number between 1 and 5. So when you run that, you could see we got 4 records displayed because the customer name is cust1, cust2, cust3 and cust4. So this is again, we are trying to club the range with %. So likewise, you can play around with all these particular set of wildcards, and this is very helpful, and especially when you appear for any interview, the wildcards is definitely in the questions list. So they are going to ask you how you're going to find particular character at the start or at the end or in the middle, or how you're going to substitute, or how you're going to use range, and what if you don't want to find anything not in that particular range. So I'm sure like once you play around with these wildcards, it'll be easy to remember. So today let's discuss about some of the most important topics with regards to the select statement and filtering the output. So today we are going to cover about select distinct command and select into command and where keyword, and in conjunction with where what all filters can be applied. So let's discuss them one by one in a nutshell, and then we'll go into a hands-on session. So to start with, select distinct. What is select distinct? I think we have already learned about how to extract the data from table using select star from. In case when you're extracting data, you might see lots of duplicates. In those scenarios, you might think, oh, why I'm getting so many duplicate records? Why can't I get the unique records without any duplicates? In those scenarios, you can actually use a command select distinct, which replaces the actual select statement. So when you use this select distinct followed by whatever columns you would like to retrieve, it always returns distinct values without any duplicates. So that's on select distinct. Now another important topic on select is there is a command called select into. What is select into? Sometimes you are in a hurry, you have to create a copy of one of the table. It can be a backup or it can be kind of a refaced version of the original table. In those scenarios, rather than creating a new table using a create command and then inserting records into it, there is a shortcut to that. We can use select into command, which will basically copies all the data from the current table into a new table, whatever name you have mentioned. And you can also filter that using the filter criteria, which we will discuss later. But for now, select into will help us to copy all the data in one go into a new table. So now, since we are talking about output filtering, so let's discuss about what commands we use to filter the output, and in conjunction with that, what other various keywords we can use. So I think, as I said, like the basic command which can be used to filter the output of a select statement is where. The keyword where defines what exactly you're going to filter using this command. So we can't simply use where. There should be some keyword in addition to the where. It can be equal or it can be any of the following, which can be in, and, or, not, between. I think the names are very conclusive and easy to understand. So to start with, in. Whenever you specify in the where clause, it basically defines what all values you are going to filter. So you can specify multiple values in the filter criteria using in keyword. And as the name suggests, it basically filters the output based on all the conditions being met. So whatever conditions you are going to put with and command, that has to be met, otherwise the output won't be displayed. Or there are some scenarios where you want one of those conditions can be met, not necessarily everything. In those scenarios, you can use or command. Not. Okay, this is, you can say like, oh, I don't want this one, but everything else I would need it. In those scenarios, you can use not command, which basically filters the output where conditions are not met. Between. Another interesting one. Between actually filters the output based on a range. It can be A to Z or 1 to 10, or it can be any date like from 1st of January to 31st of January. So likewise, you can actually specify the range rather than specifying them individually. So in a nutshell, like we can use select command in conjunction with the where clause, where we can also take help of any of these 5 keywords, which can help us to filter the output. So let's go ahead and do some hands-on sessions to get used to these commands. Okay, let's discuss in practical. So I just wanted to see what data we got within the customer table. So you could see customer table contains 6 records of customer ID 1 to 6 and for various cities and various countries. Say for example, if you want to see how many countries we got from customer table. So when you run this command, select country from customers, it's listing out 6 countries. Do you think we have 6 countries? No, because we have some duplicates. UK was repeated twice and similarly India too. So if you want to say, okay, I want to see what are the distinct countries we are holding in the customer table. So as I said, we just need to use select distinct instead of select followed by the column from customer. When you run this, you could see the output is pretty clean without any duplicates. So likewise, distinct command always helps up to clean up all the duplicate values. You can play around with any of the column. You can use country or instead of country, say for example, if you want to get distinct cities, you can also use that. So in this case, you can see it's only throwing 5, even though we got 6 records. I think one of the cities duplicated. Yes, it is. London was indeed duplicated. So likewise, you can mention n number of columns from the distinct. You can also say like distinct city from or country. So what will happen in this case? In this case, it's going to say London and UK only once instead of twice. So if you see this, yes, you could see only 5 records again, where London UK was not repeated. So yeah, so that's on distinct. So let's go into the next command, select into. As I said, select into is a very key command which will help us to create a new table in shortcut. Say for example, I was thinking, okay, from customer table I have made some changes. I got this records. I don't want to lose it in case if I make any further changes. I just want to save it somewhere. So what I can do? So as I said, we can use select into command. So the select into command can be used in multiple ways. So the first way what we can learn is we can use select star into. Here star denotes everything. Say I want everything from this table. So you can say select star into new table name, which is customers 1, from the current table, which is customers. So when I run this command, what will happen? You could see 6 rows affected. That means SQL has created a new table customers 1 and it also copied everything from customers table. So when you run the command select star from customers 1, you could see the same data as we hold in customer table. It's pretty good, isn't it? It was quite quick to create a new table and also add all the data we are holding. Okay, suddenly you might be thinking, okay, I don't want all these 5 columns. I only want set of columns into my new table using the current table. So what I can do? Similar to the previous query, instead of mentioning select star into, we will only mention the respective columns we are interested in. So we'll say select customer ID, customer name, country into new table, which is customers 2 from customers. So what will happen? When I run this query, you can actually, another important thing. Okay, while doing it, I also had another filter criteria. Okay, I don't want to hold all the customer details. I only want customers who are based in UK and India. So what I can do? You can also add a where clause to it. You can say where country in UK and India. So when you run this command, you could see only customers who are based in UK and India will be added into customer 2 table. So that means we got customer 2 4 rows affected. So we got 4 records created. So let's see what customer 2 table hold. Yes, you can see only 3 columns as we defined: customer ID, customer name and country. And you can also see the countries from only India and UK. So it's very helpful in few cases where you want to filter the record or you want to take a backup of the current table. You can always go ahead with select into command. So now, since we are also learning about the filtering, let's do some filter criteria. So as we already discussed, we should always use where clause if you want to filter the output. Okay, from customer table, I only want records from country as India. So as we define it, the way we can define is like select star from table name, where clause, what clause you want to filter. I want to filter where country equal to India. Okay, so you can see two records which are from India. Similarly, if you put UK, we can only see, I think, two records again. Yes, we have two records. So likewise, you can play around whatever column you would like to. Okay, I have learned about equal. What are the other commands? Yes, as we discussed, we have various keywords which can be used in conjunction with where clause. Okay, I think the one which we already used above, I'm going to repeat that. So what I'm going to do in this case is, okay, I'm only interested in customer details whose country in India and UK. So again, yes, you can see four records which are from UK and India. So instead of equal, we are going to put in command, and then we are going to specify what are the values. So you can specify n number of values. There is no restriction. And now, okay, now we have discussed about in, and, or, not. So let's discuss about or now. Okay, now I'm saying, okay, I want to view the customer details whose country in either India or UK. So here we are saying or clause. Or means it can be one of those conditions. So not necessarily it can be together. So what I would say is like, okay, this query will fetch any records with country as India and also any records with country as UK. So when you run this, yes, you got again four records. See, there are multiple ways to filter the output. You could see, you could say, okay, what is the difference between this and this? Both are filtering the same records. Yes, you're right. It's one way you can use in keyword. In other way, you can use or keyword. It's up to you based on the number of what you call the selection criteria. You can either use in or clause. Okay, now we learned about or. Let's go into the next one, which is and. What is and? As we discussed, it only filters the output when both conditions are met. In this case, I am saying, okay, from customer table, I got 6 records, but I want only where country is India and city is Delhi. So when I run this command, it will only fetch the record matching to both the conditions. Yes, so we can only see one record because this record has city as Delhi and country as India. So and will filter to the extreme level where all the conditions are met. Otherwise, it won't provide any output. So now not. Okay, as I said already, not will give everything else. So here I am saying select star from customers where not country equal to India. That means I want all the records which are not from India. When I run this, you could see, yes, we got all the 4 records which are not from country as India. So now there is another way we can use not keyword. How we can use is like we can say select star from customers where previously we said country in India and UK. Here I am saying, okay, country not in India or UK. So now what will happen is the SQL will run at the back. It will go into the customer table. It will see wherever customers are not based from India and UK, it's going to display the output. So here we go. You could see France and Belgium. So yes, likewise, you can play around with these commands. And other important command, yes, between. As I said, between can be defined in numeric, text or date. So let's discuss about some examples. So here I'm saying, okay, we have 6 records in customer table. Now I only want customer ID between 1 and 5. Can you give me only customer IDs between 1 and 5? So yes, you could see it has displayed 5 records as an output since customer ID is between 1 and 5. So here the one important thing you should remember is it's inclusive. It will also give 1, it will also give 5. So now I will play around with text values. So I'm saying, okay, instead of customer ID, can you just display the output where customer name between cust1 and cust5? That means the SQL will define at the back, okay, I want every customer whose name between cust1 and cust5. That means cust2, cust2, 3, cust4 will also come into the picture. And as I said, like cust1 and cust5 also inclusive. So you will see again the same 5 records with customer name between cust1 and cust5. So likewise, you can play around with multiple values. It can be numeric or it can be text. So always filtering the SQL output is very key when you're doing your filtering on the output, especially if you want to do any quick analysis or if you want to filter the output into multiple tables. So you can always use where clause in conjunction with select into, and also the select distinct can be used if you want to display only the unique values without any duplicates. Today let's discuss about another few important topics with regards to the union operator, union all, and also on the null values, how we are going to use the operators and what functions we could use for this. So I think union operator is one of the key operator which we use in the select statements. I think to give you an overview, there were two commands which are union and union all. What does union do? Union actually combines data from multiple select statements. So we can combine set of columns from 2 or more select statements where it will only return the distinct values without retaining any duplicates. Say for example, if one of the table having duplicate records, it will only list out one record when you combine the data. And most important thing is when you're doing unioning between 2 or more select commands, the columns order and the columns data type should be same. Otherwise it will throw an error, like say for example, if you're trying to combine a column which is of having a characters and against a number, you can't do that. You should have the same data type. And now coming to the next operator, union all. It is again a similar to union operator. It will do everything union does, and most importantly it will also retain the duplicate values. So wherever you have duplicate values in the select statements, it will pop them up so that the output will contain the duplicate values. So in real time you will see some instances where you want to combine data from more than one table for aggregation, or if you want to compare the data sets, you can always do that using union and union all command. And now let's come to the other important topic on the null values. So what are null values? I'm sure you might be familiar with null. Usually null means it's nothing. So basically it denotes there is no value in the field. So whenever you wanted to see, whenever you wanted to state that okay, this particular field does not contain any value, either they missed it or it doesn't return anywhere, you can always define that as a null. And importantly, it will only applies to optional and non-nullable fields. You remember when you are primary key, you always define it as not null, so you can't make that column as null. So it will only applies to non-primary keys which are nullable. So how do you actually check whether the column is null? For that, SQL has provided us with couple of operators. The first one is null. So what is null does is it will return all the records where the column is set to null. So you can use is null in your select statement. Say for example, you using the where clause, you can say where column is null. That means wherever the column value is set to null, it's going to return all those records. And similarly, the opposite to that is not null. This will only return the records where column does not contain any null values. So using these two operators, we could actually play around with select statements. And now about functions. Imagine in your particular select statement and the particular table may contain null values, but when you are displaying that as an output, you don't want to show them as null. For you more user friendliness, and especially when you want to show this as a report to any stakeholders, you don't like to show the null values when they see the reporting. So to avoid that, you can actually replace them with a value of your choice. So in order to do that, we have couple of functions. One is null and second one is coalesce. I think the naming is different, but the functionality for both is actually same. So what they both does is you can actually specify within the function what value you would like to be returned when the column is set to null. So using the isNull command, you can say that isNull. In the function, you can say column name, comma, what value you want to be substituted if it is null. So likewise, since we are primarily talking about ANSI SQL and SQL Server, we can use these two commands. But if you are working on other SQL flavors like Oracle, you can use NVL, and similarly if you are using MySQL, you can use ifNull. So likewise, each flavor will have different commands, but universally coalesce applies to all flavors, so you can always use coalesce. So in a nutshell, like this is how we define union all and null values. So since we have a glimpse of what these will do, let's play around in practical way and see how we can play around with these commands shortly. Okay, let's check the tables we have and how we can actually play around the union and null operators. So to start with, we got two tables which are nearly identical. So I have created them and I have populated the respective data in order to make our life easy. So you could see the first table is of customers. We have customer ID, customer name, address, city and country. And similarly we got customers one, which is of same column names, but it has got one extra record. So now what it does was, when you do union all, what will happen is, if you say for example union all can be done on one column or more than one column or at the table level, if you feel that both the columns are of same data type and in same order as we discussed. So when you do this, for example, you are actually defining select whatever column names you would like to view from table 1, and you are using union all in the syntax, and you are repeating it for the table 2. So when I run this, what will happen? It's going to combine all these 4 plus 5. It's going to show me 9 records, because union all always displays duplicate records. So when you see this, yes, you could see 9 records. You could see customer ID 1, 2, 3, 4 and the customer name and city from table 1, and similarly customer ID 1, 2, 5 from table 2. You could clearly see like there were some duplicates which are being displayed here. So now let's see the same column names. What will happen if you use the union command? So when you use the union command, as we already learned, it's going to wipe out all the duplicate values. So when you do this, you could only see 5 distinct records. So there are no repetition for customer ID 1, 2, 3 and 4, which are common between customers and customers 1. So likewise, you can actually filter out the duplicate values. If you don't want to see the duplicate values, you can always use union command. So instead of mentioning the column names, if you are confident enough with the column order and data types, you can actually use star as well. The same command, if I want to list out all the values, I could simply say select star from table 1 union all, select star from table 2. When I execute this, you could see we are seeing all the 9 records including the duplicate values. And similarly, if I do union command, I could see it displays only 5 records as we already seen, and these are all unique values. So likewise, you can play around union and union all based on the number of columns you would like to see, or at all columns level. Hope you're clear with this. So let's move on with the null values. So as I said, null values can be set at any column level except the primary key. Say for example, now let's see what we have in the sales table. So when I do select star from sales, it's going to show me 8 records. You could see there are some null values in the product name and quantity columns. So now let's play around with the operators we have just learned about is null and is not null, and try to use them in the select statement. So what we can do is, like, say for example, you don't want to see any record where product name is null. So it's pretty straightforward. You are going to do select star from table name, which is sales here, and using the where clause we are defining column name is null. So here I would like to see only the values which having product name is null. So if you want to see from sales table what all data set is set to null, when you run this command you could see how many rows. So you could only see one row. So let's see what will happen. Yes, it is showing up sales ID 7 does contain null value in product name column. So now in the other way, I don't want to view any null records under product name. Can you please show me the output which does not contain null value in the product name? So for that, similar to the other command, select star from table name where column name is not null. So let's do this. When you do that, you could see the record with product name is null is no longer being shown. However, we could see record 7 does contain null value but not at product name. So if you don't want to view that also, you can always say where product name is not null and quantity is not null. So when you run this command, ideally it should also remove the record 7. Yes, it is. So likewise you can play around based on the number of columns and your output criteria, you can use that. And now let's discuss about the functions. So why do we need functions? As we already discussed, we would like to see, we want to replace that in the output. Instead of nulls, we wanted to see some values. Say for example, when you run this command, you could see null values in product name and quantity. Now what I'm going to do is I'm going to use the functions. As we already learned, coalesce and is null will do the same thing but of different names. So what I'm going to do is, for the same select command which we see in output, instead of being displayed as null values, I am trying to override them with my customized value. So what I'm going to do? So I'm going to do select sales ID. I don't want to override since it's a primary key, comma, I'm using coalesce function here. So I'm using coalesce parenthesis and the column 1, in this case product name. So I wanted to see whenever I see null value in the product name, I just want that to be replaced with not known as product name. I'm doing an aliasing. So similarly, I'm using the is null function. So whenever I see quantity set to null, I would like to replace that with 0, which is at least realistic and it's of integer. So when I run this command, what will happen is it will override the null values. So you could see for row number 7, product name is no longer null, it is replaced with not none. And similarly, row number 8, the quantity is replaced with 0. So likewise, you can use coalesce, is null, and you can use is null, is not null operators depending on your requirement. So today let's turn our attention into view. So we'll discuss what is view, why do we need views, and what various commands we could use on it, and then we'll turn our attention onto practical way on creating the view and then checking various behaviors of it. So to start with, what is view? A view is a virtual table which contains data from one or more tables. So that means we can create a view using the data from just one table or more than one, like 1, 2, 3, so on. So what happens to the data within the view? A view will refresh every time user queries it. So that means in case after creating the view, if you have changed some data within the main table, so whatever data which has been changed will reflect in the view when you do a select statement next time. So we'll discuss in detail practically later. But before that, why do we need views? So we need views for various reasons. Say for example, you have created a complex query where it contains data from more than one table and you have used joins, you have used where clause, you used group by, etc. So that query will be useful if you can store that in some table so that every time you want to view the result, you could see the result instant rather than repeating the steps of running the query again and then storing the result. So to avoid such circumstances, we could simply create a view with the result set from that particular complex query, so that we can simply query the view which will give us the latest data set. So that's one requirement. And similarly, a specific purpose, say for example you have various business users or various stakeholders who want to view particular data set from the entire database. So in those cases, you can just create a specific view covering their requirement rather than creating the access to the whole lot of tables, which will even confuse them. So in those cases, we can create a view. And the most important thing is security. So as a measure of security, you don't want everyone to access all the tables. Again, you would need to use the grant command and revoke to do the accesses. So to avoid these, wherever possible, we can simply create a view, whatever relevant tables data they would need, and then based on that, the user can actually view the data rather than querying onto the actual tables. So these are the various reasons, but not limited to. There will be different requirements from different people, but in the end, like view is kind of a virtual table which holds no value like a table. Like the table will have some physical space, whereas view will have very limited or no space within the DB. So what various commands we could use on views? So like our tables, we can use all the DDL, where we can use create, we can use drop command, we can use like DML like update, delete, we can use DCL like grant, revoke. So you could write all those commands here like create, drop, delete, grant, revoke. So you could use everything. So similar to tables, we can play around the various functionalities of the view. But for now, I hope you got the crux of what is view, why do we need view, and what various commands we can use. So let's go into a practical way to see how to create the view and how to play around with these functionalities. Okay, as we already discussed about views, so let's check them practically. So what we can do is like, I'm just first querying what data we got within the customer table. So we got like 5 records. So now I wanted to create a view using this particular table to start with. So what I want is like, I will create a view called customers UK as. So the syntax starts with like create view, view name as, and whatever we want, whatever command we want, like from the select statement, what all columns we would need. And if you want to apply any specific filtering on country, you can always do that. So say for example, okay, I'll apply the filter. I'll just say that, okay, can you create a view customers UK from customer table? I only want 3 columns and I want to restrict the data for country equal to UK. So when you do that, so if I create this, what happens? Yes, command completed successfully. So that means the view is created. So let's check. So again, how to check it? Similar to a table, we'll just do select statement, select star from customers UK. So you could see now the customers UK only hold data for 3 rows, which are part of country UK. So since we are only filtering 3 columns, we couldn't see all the 6 columns like customer table, but at least now we can see the view is created. So now, since the view is created, as we already discussed, let's play around some DDL commands. So before that, one important thing, as I stressed out at the start, so any changes to the main table will reflect the data within the view when you rerun it. So let's check that particular statement now. Say for example, for the customer table, for the customer ID 5, I want to change the customer name to customer 50 instead of 5. So now let's do that and see what happens with the view. Okay, the update statement successful. So let's check the data in the customer table first. Yes, you could see the customer name is equal to customer 50 now. So now let's check the respective view and see whether it's reflected or not. Yes, it is. It is reflected correctly here. So that means it has proven that whenever you made any changes to the main table, it will always reflect in the view when you run it next time. So now, what if I want to view if I want to change the data within the view? Say for example, I want to update for customer ID 6, I want to update the customer name as 60. So remember, it's updating in a view, not in the main table. So when you do that, one row is affected. So let's check the view. You could see customer ID 6, the customer name is 60. So now let's see what happens to the main table. So when you do that, you could also see the main table is also updated. So that means even though you have not updated that table, since you updated that as part of customers UK view, it's reflecting in the main table as well. So it's always maintaining that referential integrity. So as long as the table exists, the view exists, and the table get dropped off or deleted, then all the data within the table, then the corresponding changes will also reflect within the view. So keep in mind, you always cater the latest data set when you run the view. So now let's play around some DML commands. So now what I want is I want to delete the data where customer ID equal to 6. So I'm doing delete from customers UK where customer ID equal to 6. Okay, one row impacted. Now let's see how many records we hold. Now we hold only 2 because we deleted customer ID equal to 6 row. So that means the delete statement is worked. So now what if I want to drop the view altogether? Okay, the specific purpose has been met. I no longer want to save this view. So then you can simply use drop view and view name. That's the syntax. So let's drop this. Command completed successfully. So now if you query customer UK view, you could no longer see that available. Yes, it is invalid object name. So likewise, you can play around all the DDL, DML, and all the create, drop, select, update, delete, etc. So since you have already seen how to create the data from one table, let's extend that to more than one. So in this case, I want to create customer sales table where I want to get the data from more than one table. In this case, I would like to join the data set from customer table and sales table. So where I'm doing an inner join, and also I could put up some clause if you want, say similar to what we did previously. We can simply say where c.country is equal to UK if you want to. But in this case, let's remove that. So let's create the whole data set. So now let's see what happens if you do this. Command completed successfully. So now let's check what data we hold as part of customer sales table. You could see the name is appearing over here. So that means the view is created. Here we go. So now we could see the join clause and whatever inner join we did. We got 5 rows, like 3 for customer ID 1, and we got the respective city from the customer table, and we also got the product name from the sales table. So likewise, we can play around based on the requirement. You could select the subset of the data, and you can always apply the filters. You can apply the join conditions, group by, union, everything. So literally whatever complex statements you want to use, you could use everything in one select statement, and you can just create a view, which will always helpful in case if you want to view it for various purposes as part of your SQL work. So that's how we'll work on it. So again let's drop this if you want to, similar to the above command. If I drop it, yes, it is dropped, and I could see the data is no longer present. Discuss about a couple of important things which we always come across when we are doing data level validation. I think we all will be wondering how we can compare the schema validation for each table whenever required. And similarly, we also have a scenario where we would need to compare the data between 2 tables. So let's cover these 2 things in today's session, and I will also go along with the practical queries to do this possible. So to start with schema validation. What is schema validation? As we all learned previously, as part of table structure, we define the table and the column data, and we also say that what is the data type of each column, whether it is nullable, and what is the length of each column. So to check the schema, whatever we have defined, in case in future when you're working on any data level projects, if you want to check the schema whether it is as per the requirement. So for example, if you want to compare the table structure which is as defined in the requirement, and to check the nullable definition of each column, whether the column is allowed to be null or not, and to check the length of each column, whether the column length is defined as per the requirement, and similarly, and the most important thing is about data type, whether the data type is defined correctly, wherever character or wherever numeric, whether we have defined the respective correct data type. So these things we can check using SQL queries. We'll go through that in practical. So but now let's assume that whenever we would like to do the schema validation, we are going to check these particular things in common. So moving on to the next topic about comparison query for data validation. So what is a comparison query? Say for example, you have defined some tables and you started working on whether you're developing or testing, whatever your role is. There will be a scenario, oh, I would like to see whether the source data has been fed correctly to one of the tables. So if you want to move data from table A to table B and you wanted to make sure the data from table A is copied correctly to table B. So how do we do that? So in order to do that, we should have a query which will actually compare the data between two tables. So it can be a table name or it can be a view name. It always stays same as both will have the columns. And similarly, we would also need to see whether the row counts are matching between both the tables, and most importantly, whether the data which is underlying covering each row is same across both the tables. So in order to achieve that, we should prepare a comparison query, which I will showcase shortly. So there we will use some aggregations, we will use some group by, and we'll use some union command to ensure we merge everything and then we compare. So this is a very important query which can be used across any data set as long as you know the table name or view name along with the column names. So let's look into that in practical way. But again, as I said, these two are very important topics whenever you're working. So let's move into practical. Here we go. I think to start with, I've actually created the table level data and I've also played around with a couple of tables to ensure we have some differences, and then we can compare the data between these tables. So to start with, let's cover the schema level validation first and then we'll move on to the table level validation. I think as I said, in order to compare the data across each table, before doing that we'll do the schema checks. So we are going to compare what columns it contain and what data types it contain and whether it is nullable or not, and the length of the table. So in order to do that, we got a ready-made query within the SQL where we can use a particular schema name called information schema, and it has got some object level data, like it can show up what tables it has, what columns it has, etc. So to start with, if I simply search select star from information schema.tables, what will happen? It's going to show up what all tables we have within this test database. So when I execute this, you could see, yes, we got around 6 tables which of different table names which we already created, and there is also one view called customers underscore UK. So we got 5 tables and we got one view. So we can easily differentiate based on the table type. So information schema dot tables will always give us the view of what tables or views we have. So we can always use this for validating the table names. Say now I would like to see the structure for customers table. So I wanted to see what columns it has and what data types it has. So in order to do that, so first I would like to see whether the table is really present. So you can do that by using this select star from information schema dot tables where table name is customers. So when I do that, yes, it is available and it is a base table. So now I'm going to check the column level. So when you're checking at the column level, you could see clearly this table has 5 columns, which is customer ID, customer name, address, city, and country. And you could also see the ordinal position of each column. What is ordinal position? The position of the column in the table structure. That means it starts with customer ID and customer name and along until customer country. So likewise, you could see the ordinal position of each column, and you could see whether it is nullable or not, which is very important. So we can see, like, if it is no, means no, it can't be nullable. You know why customer ID is not nullable? Because it's a primary key. Primary key can never be nullable. And then you have customer name, address, city, and country. which are all nullable as we defined while we creating the table. And next thing about the data type, it is clearly showing the primary key, which is customer ID, is of data type integer because it's an ID. And similarly, the customer name, address, city, country all fall under varchar, which is of characters. And the length, when we defined, we have given a maximum length. That's why it has given 255. So likewise, you could see various other characteristics of each column, and I don't think the other things are very important. I think the key things we would need to check for each column are what is the column name, what is the ordinal position it is, and whether it is nullable or not, and what data type it is, and what is the maximum length. So if you do this query, and when you run this, it will only give you the subset of the data, which we already shown. So these are the key checks which can be done for each table level schema checks. So whenever you want to do the specific schema check, you can always use the same query and you can input your respective table name, and you could see all those key details starting from column name until the length. I hope this is clear. So let's move on to the table level data validation. So for the table level data validation, again, as I said, we would need to compare data between various tables. So the tables can be same or cannot be same. So that's the idea behind this query. We would like to see whenever the table data is mismatched, we wanted to show that, and whenever the table data is same, ideally there should not be any differences. So to achieve that, what I did was I created 3 tables. So I've created 3 tables called, I think, customers table, which we already knew. We got like 5 columns, and now I also created customer 1, which is of 5 columns, and more or less I think the data set between customers and customer 1 is same. You can clearly see it both contains 5 rows and the data is almost, I think it's same. So similarly, I've also created customers 2 table, which is actually a subset of data. You can see that it is only having a 4 rows. So now what I wanted to achieve is, I would like to compare the data between customers and customer 1 as my case study 1, and as my case study 2, I would like to compare between customers and customer 2, or you can even do customers 1 versus customer 2. So to do that, as I said, I'm going to use set of aggregated functions, set of group by, and also other functions. So to start with, I'll first define you how to actually write this query, and then I'll go ahead with this. So the query which I use, it's very generic. You can play around with the number of columns and number of table names, and you can always compare between table A and table B. This is a very good query which can be used in your real-time environment. So the way we define is, if you clearly see, I've used so many functions. I've used min, aggregation, and I've used union all, and I've used group by, I've used count. So what is the idea behind this query? I will explain. So the first thing which we need to keep in mind is, when we are comparing the data between table A and table B, we should put up the column names we would like to compare. Imagine in real-time scenarios, you cannot compare the data between all columns. Say for example, table A has some metadata column like an inserted date, and when you are copying that data into table B, the inserted date or created date can be different. So ideally, you should take the key columns which we use for comparison, and you can always use other columns, but it will give you the differences. So the way we do is, like, the query which I prepared, actually what it does is, I'll explain bit by bit. So the first key bit I would like to show you is union all command. So what I wanted to do as a stage 1 is, I would like to union the data set between table A and table B. In this case, it is customers and customer 1. So what I'm doing is, to differentiate the data, I'm creating one column which is actually creating my what do you say, like ad hoc column. So which I'm saying as customers, and I'm defining the column name as tab. So this will define me that, okay, this data set is actually belong to customers table. And similarly for table B, I'm creating customers 1 as tab, which is table name. You can also create as table underscore name. It's up to you. And then I'm defining what all columns I would like to compare. So as we already discussed previously, for this table we have 5 columns, and I would like to compare all the 5 columns because there are no metadata columns in this case. So when you're doing that, you should always make sure the column count between table A and table B is always same. So you could see we got 5 actual columns and 1 ad hoc column which we created for our own preference of identifying the data. And similarly, we in table B we have the same 5 columns along with the dummy column. So you could see as a first step, I'm actually combining the data between customers and customers one. So what UnionAll does, we already discussed that previously. It will combine everything irrespective of the duplicates, so which will contain duplicate data. So now since I have combined it and I have also created a distinct column which is of tab, which will define me what table level data it is. So now what I'm doing is I'm actually creating an aggregated function. So I'm actually doing a group by. So I'm grouping this data between these tables on what columns? Again, those 5 columns. I'm grouping the data on these 5 columns, and then I'm asking to show me the SQL. Okay, can you give me only the data set where count star equal to 1? What is count star equal to 1? The count star, this actually denotes all these 5 columns. So I would like to see wherever the data set contains only in one table but not in other table, can you display that to me? So that is the definition of count star equal to 1. So now on the top I'm saying like, okay, can you display me min of tab as tab? So basically I would like to show whenever there are differences, can you show me the minimum of table name as table name? And then I would like to see the data of all the 5 columns. So this query, as I said, what it does is it will first merge the data using the UnionAll, and then it will group by on those particular columns, and then it will pop out whenever there is a data set which is present in one table but not in other, using the count star equal to 1. So if we say equal to 2, definitely it exists in both table A and table B. So that's the reason I'm only asking to show me the data where count star equal to 1. That means it exists only in one of those tables. Then similarly I would like to display the table name also. So what will happen if I run this query? So remember, as I said, there are no differences between customers and customers one table. So now what happens is when I run this query, you could see no data, but query is executed successfully. Why? Because the both tables having same data set. So that is the reason the SQL has run those aggregation and grouping, and it has found that there are no mismatched rows. Now let's use the same query on other table. As we know that customers 2 table contains subset of data. So when I use that on the customer 2 table, what will happen is, so in this case I'm trying to compare data between customers table and customers 2 table. The remaining code is same as above. So that's the beauty behind this query. You can use the same query, you can extend it according to your number of columns. So now when I run this query, what will happen? Any guesses? I think we all knew the customers 2 and customers table does not contain the same data, because customers 2 has a data where column level, one of the column has actually missed in the customer 2 table. So when I run this table, so what will happen is, as you all know, you could see, okay, 1 second. Oh, I think I need to put yes. So now when I run this, you could see customers table has 5 records and customer 2 table has 4 records. So now what will happen? When I run this comparison query, ideally it should show me that missing record which is present in customers but not in the customers 2. So you could clearly see it's displaying the missing record because all other records are same. You might think, okay, we discussed when there is a data, when there is no data. What will happen if the data is present in both the tables but it is different? Yes, we can also cover that bit. Say for example, so let me play around something. So we all know that customers and customers 2 table is having similar data except one record. So now what I'm going to do is like, I'm going to update one of the record in customers table to make it different from customers 2, or otherwise I would like to update in customers 2. So what I'm going to do is like I'm going to set city equal to Glasgow, where, remember we should always put the where clause, otherwise it won't match. So I would like to put that for customer ID equal to 4. So I'm going to put that customer ID equal to 4, and when you do that, you could see one row impacted, and now when you run this query again, you could see for customers 4, for customer ID equal to 4, you could see the city is London in customers but Glasgow in customers too. So now let's rerun the query again, the query which has showed us one missing record. So now what it will show, ideally it should show 2 records or even 3 records. It should show what is the missing record between table A and table B, and similarly the record which is altogether missing from table B. Now when I run this, see, you could see it has thrown us 3 rows. So this row is clear, this is completely missing record because the customer ID 5 which exists in customers table but it's never present in customers 2 table. So now what happens to the customer ID 4? You could clearly see when you compare this data, the city is actually mismatched. It is Glasgow and it is London. So that's the beauty of this ad hoc column which we defined, which will clearly show us, okay, what data set contains what table. So here you could see like customers table as this data and customers 2 table as this data, and you can clearly see it is not matched. That's why it has thrown us. So likewise you can play around with this query. So this will actually compare the whole data set. So it will compare the column level data, it will compare the counts, it will compare the data set against each column. At row level it will see like how many rows are missing, and wherever the rows are mismatched it will pop out. I hope this query is will help you out whenever you do any data level validation, whether you are a developer or tester. I'm sure I have used this many times. So definitely I think this is the way if you want to compare the data set between 2 tables, and you can play around with this query. You can extend it, you can shrink it according to the number of columns you want to compare, and you can also compare against views as well if you want to. I hope this helps you to understand the schema level comparison and data level comparison. Thank you all, and please do like, share and subscribe our channel. Signing off, Suri.